Okay, this is module 4, and I'm really going to focus in on a word in this module, and it's interdeterminacy. I've been using this word, and I coined it for the real estate valuation problem presented in a sales comparison analysis because when we're talking about math, how to solve the numbers in predicting price. Okay, so I've got different variables, different adjustment factors, comparables with different prices, and I'm trying to isolate different effects and quantify those in order to predict price. Well, we've got a mathematical system that we're dealing with. And we can think of mathematical systems, simply in sort of black and white terms. You have determined and undetermined systems. Determined systems are one where there is a mathematical solution. And typically we think of those as uh, if we're doing, linear algebra, do I have more data points than I have variables? If I do, then that leads to a determined system. Whereas if it's flip-flopped, I've got more variables than I have data points. I've got an undetermined system. There's an infinite number of ways to solve that system mathematically. So this leads to a lot of very wise appraisers have said, hey, make sure that you've got more comps than you do adjustment factors. That makes sense. What they're trying to do is say, hey, make sure you've got a determined system. The problem is that we have something that's a little bit more complicated in our real estate markets, and that's the fact that variables themselves interact. Sometimes they will be relevant to one another in terms of how the effect is perceived by the market or is reflected in the data. So there's a couple different kinds, and I want to talk about each one right now. So let's look at this little visual here. So the first type is organic interdeterminacy. And we can think of that as how the market is shaped. And so if we think about how are the actual human buyers and sellers thinking about real property and the differences therein, how does the market function in terms of differences? I've used the example before of view. So how the market perceives the view, it may be related to other factors such as how many windows do we have that face the view? Do we have a one-story or a two-story property? Do we have a covered patio or not? What's the frontage on this particular maybe adjacent influence? So those are all things that are organic to a market. They're actually market participants evaluating different features and the desirability. So last time I talked about the fact that we're talking about hedonic modeling. So, how much pleasure am I going to get from that view? That's this idea of a hedonic model. It's important to note that the the importance of dealing with interdeterminacy is that we need to make sure that our model is reflecting the actual market. So, if we were to think about, I use this term model, let's just think of it very broadly in terms of a sculpture. Well, if I am creating a sculpture of a particular person, when I'm done with that sculpture, it needs to actually look like the person, or it's not a very good sculpture. It's not really going to help people to know what that person looks like. So that's why my model needs to be shaped like the market is shaped. So my model, being my sales comparison approach, needs to be shaped like my market is shaped. And so that part of respecting and reflecting that shape is in how I'm selecting different metrics, how I'm applying and recognizing interplay between different adjustment factors. But there's a second kind, and this is kind of already touched on. This is structural interdeterminacy. And if we think about structural interdeterminacy, we're not talking about the shape of the market, we're talking about the shape of the data. So if you look at this image here, it's a correlation matrix. Well, that's how you measure the shape of your data in terms of variable interrelation, or it's a way that you can measure that. And so it's important to note that the shape of your data may not always reflect the shape of your market. Ideally, it would. So this is where we maybe talk about the idea of sampling. And there's an ongoing debate as to, well, are your comps, are they a sample? Are they the population? What should you use? Some people are like, forget comps, let's just use the whole population. And that is an idea of, hey, you know what, let's not arbitrarily shape the data in a particular way. And while there's wisdom in that, there is something missing. And the fact is that we're never dealing with a population, because the population isn't real estate. The population is people. It's it's effectively all humans who would be participating in a given market. And it's not just the number of people that create the population, it's the number of potential interplays between buyer and seller. So each of those potential participants acting as a buyer, acting as a seller, and how they combine together. There was somebody who commented on my last post, and they used the same analogy that I have around a soup. Any transaction is really like a soup. You've got lots of different ingredients. Well, the ingredients aren't the ingredients aren't the real estate. The ingredients aren't the number of property elements that are all combining together. The ingredients are the people. And so the real estate and the different features of real estate are the context in which the market interaction between the people are taking place. So no matter what we're looking at in terms of how large the set of data is, there's always going to be the possibility and likelihood in a lot of cases that's not actually, you're not actually going to be able to perfectly reflect the shape of the market, because that data is never the full representation of all possibilities. In fact, every time you have a new sale, even if it's the same property, you have two different, well, maybe at least one different market participant that is involved in any new transaction. So, so that's important to recognize. In that, what are we trying to do? The sales comparison approach, we're trying to model a system, and we want to be able to do that well. So what are the implications of this, and what exactly do I mean by a system? And we're going to talk about that next time.